If you want to get into space robotics, you might find your start in robotics competitions and battle leagues. This week on Planetary Radio. I'm Sarah Al-Ahmed of the Planetary Society, with more of the human adventure across our solar system and beyond. As humanity aims to explore new frontiers in space, the need for good roboticists has never been greater. Robotics leagues offer an excellent gateway into the field, connecting aspiring engineers with a vibrant community where enthusiasts can learn, compete, and innovate together. Our first guest today is Kelly Biderman, the CEO of Havoc Robotics. She leads the National Havoc Robot League, the world's largest series of robot combat tournaments. Then we have the privilege of hearing from Florence Pouya, the former captain of the Afghan Girls Robotics Team. Florence shared her insights with our senior communications advisor, Matt Kaplan, during their time at the Humans to Mars Summit in Washington, D.C. earlier this month. Then we're going to check in with Bruce Betts, our chief scientist, for what's up and a new random space fact. If you love Planetary Radio and want to stay informed about the latest space discoveries, make sure you hit that subscribe button on your favorite podcasting platform. By subscribing, you'll never miss an episode filled with new and awe-inspiring ways to know the cosmos and our place within it. Robotics plays a pivotal role in exploring our solar system, allowing us to reach and study environments that are otherwise inaccessible to humans. Robotic spacecraft, landers, and rovers have been instrumental in gathering data from other worlds, teaching us more about their composition, climate, and potential for life. These sophisticated machines are equipped with advanced instruments and sensors, which enable them to conduct experiments, capture high-resolution images, and in some cases even drill into the surfaces of distant worlds. But each robotic spacecraft is engineered back home on Earth, and building them requires unique skill sets. There are many ways to get into robotics, but one of the most fun and collaborative ways to learn how to build systems that can help us explore our solar neighborhood is through robot competitions and battle leagues. Robot battle leagues are fun to watch and a blast to participate in. These competitions involve teams designing, building, and pitting their robots against each other in intense combat. These leagues provide a unique platform for innovation and problem solving because participants have to continuously adapt and improve their designs to stay competitive. The excitement of these battles, combined with the community's collaborative spirit, makes these leagues a breeding ground for creativity and technical skill. Our first guest today is Kelly Biderman, the CEO of Havoc Robotics. She leads the National Havoc Robot League, or NHRL, the world's largest series of robot combat tournaments. Through NHRL, participants hone their technical abilities and become part of a supportive community, ready to tackle the challenges of battle and build the skills necessary to explore our cosmos. Kelly's mission is to discover and promote the next generation of STEM leaders and to develop a new category of intellectual and innovative sports, or iSports. Before joining Havoc Robotics, she held senior leadership roles in operations, strategy, and digital transformation at Katie Couric Media, Dow Jones, and the Wall Street Journal. Still, I think we can all agree that watching a crowd cheer as a bot with a saw blade and a bot with a flamethrower go head-to-head might be way more fun. Hi, Kelly.
Hi, how are you?
Doing really great, and it's wonderful to have you on Planetary Radio. As a kid, I was so into things like battle bots and robot wars, and at the time, it was one of those things like we were really excited about it, but we couldn't really build our own robots. We would make fake ones with Kinects, as an example. So it's really fun seeing how far robot combat has advanced in the last 2 decades.
Yeah, it's just been an amazing journey for the sport and for the fans. And NHRL is the company that I run. And to be able to have this opportunity to make robot combat more accessible and really bring it to new audiences has been just an amazing opportunity. We're really excited about what we're doing.
Could you tell us a little bit about how you personally got into the world of robotics and eventually into leadership at the NHRL?
It's a really short story. I don't have a background in STEM or robotics. I spent my career working in media and journalism. You know, we were founded by a guy named Austin McCord, who's a successful tech entrepreneur, and he launched NHRL first as a hobby back in 2018. And when it started to get some legs, he decided that this was something that needed a person to really run it and turn it into a business. And when you love something so passionately as a hobby, you don't really want to ruin that and sully that by having to worry about the business part of it. So I was able to get connected with Austin. And after almost 15 years in media, I was really just looking to build something new that felt like it just had a ton of opportunity around it. When I first met Austin and when I got to really see what he was building with NHRL, I immediately knew there was a there, and that there is just something that is really amazing about NHRL and about robot fighting that just should matter to more people. So I was really inspired to come and take that on.
There are many different robot combat leagues around the world, but during the time that you've been CEO of the NHRL, you've seen a tripling of the number of people that have been getting involved. How many participants do you now have in these robot battles?
Yeah, I mean, the tournaments have grown like crazy. When I started, we had around 65, 75 robots per tournament. And last year we hit 250 robots in a tournament, at which point we had to cap it. We just couldn't handle anymore. We've restructured things a little bit to make sure that it's manageable operationally for us and also like provides the best time for the competitors. And we've added more events and all of that to be able to manage that scale. But we have over 10 tournaments this year. Each one will have about 150 175 robots, hundreds of builders come along with those robots, and then thousands of fans. And we've seen that growth. I mean, about 20% of the competitive field of each of our tournaments is rookies. So we really have seen that amazing growth of the sport. That's a testament to our builder community and to the welcoming nature of that community and also of the sport. And, just being able to bring more people into it is obviously a huge part of the goal and part of what we want to be able to do. And so to see that growth and to see that enthusiasm has just been really rewarding.
Are there different weight classes, for lack of a better way to put it, for these robots?
Yeah, so I can tell you a little bit about robot combat for those listeners who are not super familiar with what we do. But remote controlled robots are fought across 3 weight classes at NHRL: 3 pound, 12 pound, and 30 pound. And those robots are built with materials ranging from 3D printed plastic to steel and titanium. Each robot features a weapon like a spinning saw blade or a flamethrower. So if you picture, they fight in arenas that are constructed out of steel and bulletproof glass. So if you picture a fish tank and you scale it up to the size of your dining room, that's what we're talking about. And each robot fights in a 3-minute match inside one of those arenas, and they end in knockout, tap out, or judge's decision. So it's not dissimilar from something like wrestling. Bots progress through a bracket style tournament, and the winner of each match has at least 20 minutes to repair their robot or they're eliminated. So it's super fast paced, really competitive. Winners are competing for a cash prize. They're competing for the coveted golden dumpster and a place at our annual World Championships tournament. And yeah, tournaments are open to anyone. They're attended by thousands of builders from around the world each year. And we're really at this point kind of bursting at the seams of our building that we call home, which is based in Norwalk, Connecticut. It's a building we call the House of Havoc. It's a 60,000 square foot warehouse that was originally a toy factory. And we like to say it was once a toy factory and we've turned it into a joy factory. And that's really just part of why it's grown so fast. Is it's just so fun and so entertaining and so exciting. And to be able to do that in a STEM space is really, I think, part of why it's been so successful. There's that increased enthusiasm around STEM. And then we're able to create this great content and build a really great social audience, live stream our tournaments to thousands of people around the world. And it's just been really rewarding to see that journey happen.
It's been really fun seeing these competitions actually end up on my social media feed more recently. In short form video, you get these little bursts of these robot battles, and it's really exciting. But what is it like actually being there during the tournaments? I imagine it's electric.
Oh, it's like the most infectious and fun environment. And like I said, I did come from a STEM and robotics background, and so I don't have an enormous frame of reference to compare it with previously. But our events just feel really fun, and our competitions and the competitors are intense, but it's a community that is just as collaborative as it is competitive. And I think that's the beauty of doing something with lots of engineers. Is the only way that they get better is by competing against the best. So they actually just want to help each other and they want to support each other. And whether that's in our Discord server between tournaments, sharing CAD designs and helping troubleshoot things and welcoming new builders in and answering their questions, or whether it's in the pits at our tournament and they're like, hey, I need this drill, or my frame got totally bent in this last fight and I've got to repair it in like seconds, and somebody else is knocked out of the tournament. And they're like, yeah, sure, let me help you out, because it's just like the thing that they love to do. And that joy and their enthusiasm is really contagious. And that's just part of what has inspired us to look at this as building a new sport. It's the foundation, we think, for a new category of sports, but it's power tools trying to kill each other. It's a lot of fun. And with that, like you picture a drone with a butane tank attached to it opposite, a modified lawnmower with an axe on top. And you're just like, why wouldn't this be fun to watch? You see two 30-pound robots hit each other, and you're next to one of these arenas and you feel it. And that's just part of why we have so many fans that come to watch and so many people that then feel inspired to get involved. And we see that as changing the perception of STEM and changing the perception of engineering, and kind of deconstructing a lot of perspectives and outdated and ancient views on what being a nerd is. I think that we just are like so celebratory and open about like, that's who we are. We're so rooted in trying to make it as accessible as possible, really inclusive. And I just think it's magical.
It's really powerful to have these ways of making these things more accessible, but also feel more acceptable. When I was growing up, I was definitely a space nerd, but at the time it wasn't as acceptable. I got picked on a lot and made fun of. And now we have entire generations that are now like, oh, you build robots? That's cool. You love space? That's amazing. And I feel like these things are finally making it approachable and something that you can wear as a badge of honor as a person instead of something that you hide. And I really value that about these robot leagues.
Absolutely. I mean, like we think about it in some ways of traditional sports, and I'm an ex-swimmer. I was an athlete my whole life, so this is not a knock on traditional sports. But like we think about it as there have been for generations people who put a poster of a famous tennis player, basketball player, football player on their wall, and that's what they aspire to be. And we look at our community of builders and we think the future looks like these people being on the posters that are on some kid's wall that is at NHRL making their own poster to say, go JMO or go Dutch oven or whatever the robot might be, whatever the builder might be, building up those fandoms and really treating our builders like the celebrated athletes that have always existed, and really just trying to create new icons and new aspirational figures that are changing the face of STEM and changing the world quite literally with the technology that they're using and the careers that they go on to have. And that's that direct connection between this being a sport that people are getting involved in. And on the other end of that, they might have a career in aerospace or a career in some kind of engineering discipline, is just like such an amazing through line. And it just is a great environment for people to learn these incredibly useful skills. We look at inclusion in a lot of different ways, but we really try to focus on lowering barriers to entry as much and as often as possible. And that means looking at things like cost and education and the inclusiveness of our community as things that we have like a degree of control over. And increasingly, we look at things like philanthropy and proactive outreach and partnerships as mechanisms that we can also leverage to generate more diversity across our competitive field and generally help to grow the inclusiveness across the community and diversity across the community. And so things like what we do is we run open tournaments. They allow anyone to enter. We don't charge a registration fee. It's just a refundable deposit to hold your place. You can sign up as an individual. You can sign up as a team. You can sign up as a group of friends. You can be from a college. You can be a retired rocket scientist. You can be a parent-child team. It's a whole variety of people who are shoulder to shoulder in the pits at one of our tournaments. And beyond that, we've launched Havoc Academy, which is our education arm. And we're in the process of launching our first product, which is called Crash Course, which helps people learn the basics of how to build a robot. And so that is, another mechanism that we can use to try to bring more people into the sport and into the world of robot fighting. And we see a lot of application for that across education, a lot of appetite from teachers who come to our events or who are associated with teams who are like, hey, how can we get this into our classroom? Because they see that this is something that is destigmatizing STEM and destigmatizing these hobbies. But it's really about like encouraging people to come and take their weird idea and make it reality and to learn how to do dangerous things safely. And it's possible because there's this enthusiasm that is building around STEM and around engineering, especially among young people, there's so much content and so many content creators out there who are helping people learn the basics. You can buy a 3D printer at Home Depot. All of these things are allowing people to harness their excitement and creativity. And then for us, it's like, okay, how do we just make NHRL the most accessible and fun and encouraging place for people to get started?
I had a very similar emotional response recently. We had our Eclipse-O-Rama festival in Texas, and gathering people together who are also passionate about something, instantly the friendship and the camaraderie clicks together. And I heard that so many times over that weekend. Just, I found my people, and it's beautiful seeing the walls just drop and everyone suddenly being so passionate about everything they're interested in ways that they might hide otherwise.
I think that's called collective effervescence. That is a term I've heard used, where it's like all of these people are together and they're just like so joyful or united around something that is just universal. They're all experiencing the same thing and joy about the same thing. And I love that in a world that just feels really divided, to see everyone just coming around and excited about something, regardless of who they are and what their background is something really special.
What you just said is so reminiscent of something that I heard very recently. I was doing an interview with the team from National Geographic who did a documentary called The Space Race. And it was about the experience of the first African-American space pioneers, essentially. And Guy Bluford, who was the first Black man in space, said basically that he was under such scrutiny in space that he didn't even have time to look out the window. He barely even focused on the fact that he got to be in space because he was so driven to make sure that in that role, he could be a role model for everyone else so that it would open doors for everyone that came after. And it's really beautiful seeing STEM just generally open up over these last decades to more people, and what that variety of experience has really added to the field. Every new perspective that comes into STEM allows us to do new and cool things that we would never been able to do before. And I'm sure you just being in that role has probably inspired a lot more people than you even know.
I hope so. I certainly try to build strong relationships with our community and work with people to figure out how we bring more women in. Women in STEM is something that is new to me. And so I'm on my own journey of discovering what are some of the systemic issues that have led to that lack of diversity, being able to learn and borrow from other industries that have worked to overcome that, but also recognizing that there are a lot of unique and very specific challenges, frankly, like what we were just talking about around the social ostracization of people in STEM. When I was younger, it was so gendered, and I think that a lot of that still persists. And to be at the helm of an organization that is building a sport that is not one of the only, I think it probably is one of the only sports that doesn't have a men's league and a women's league. And that's part of just the magic of what we do. It's like everyone has a brain, and everyone's brain is as capable as the next person's. And to be able to focus on that and to destigmatize and to decentralize gender from a sport is also something that is really empowering. And yeah, I mean, I hope that brings more and more people in, whether they're men or women. You know, we have a really significant LGBTQ plus community in our space. And I think that a lot of that speaks to just the degree of inclusivity of what we're doing. And yeah, I hope that's something that in the years to come that we're known for, is to be able to help break down some of those barriers and bring more people in and help them find their people.
Have you seen anybody go through this BattleBot competition or go through the NHRL and then come out the other side with careers in aerospace?
Yeah, we see NHRL as a new way to find and develop the best engineers for all sorts of disciplines, but particularly for space exploration. I think there's so much promise there. Our competitors are, quite honestly, like the most brilliant engineers I've ever met. I am constantly blown away by their designs. They're just so creative. Our rule set really encourages that kind of like creativity and that innovation. And our community is, for better or worse, constantly trying to push the rules to their limits, which is exactly what engineers do. They're given a set of constraints and they have to innovate within that series of constraints. And we have to continue to raise our game to be able to compete with that, which is exactly what builds the kind of rapport and transparency we have with our community. It makes them that enthusiastic about what they're doing, and it makes them want to do this because not only do they have a lot of fun and watch great fights and compete in great fights, but they also become better engineers. And so our competitors who work in aerospace engineering are typically mechanical engineers at companies that are manufacturing satellites or space shuttles or military aircraft or drones. And they're also people who work more on like the data telemetry and software side in fields that are like either directly related to aerospace or in adjacent fields like autonomous vehicle software engineering. And so, of course, right now that industry in and of itself is in such infancy, and there's just so much opportunity for people to grow those careers. And our sport, autonomous robots, it's really at its infancy in our sport. And so to be able to know that's total white space and that people are starting to experiment with it, but knowing that's an area that is going to be so significant strategically for us to expand into is just exciting, because I know that's such a huge priority, of course, across the industry.
We really need that kind of innovation in the space industry. We've done a lot to create autonomous mechanisms that can figure out safe landing sites and all kinds of stuff. But the deeper we go out into the solar system, the more of these things we're going to need. Mm-hmm. There's going to come a day where we're going to need robots on Europa trying to dig beneath the ice. And that's going to start with things like this, people tinkering around with their own little robots.
Yeah, absolutely.
Are there any specific innovations that you've seen that we might be able to apply to aerospace?
I think that aerospace is an industry where obviously they continue to push the boundaries of material properties, and things like strength to weight ratios are critical, and fatigue strength is critical, and graceful material failure is an important consideration. And all of the best NHRL teams are making all of those considerations all the time. I'm not an engineer, so like specific innovations is not an area that I'll be able to authoritatively talk about, but I think that competing at NHRL contributes to so many of the skills that you need to be involved in aerospace engineering. And so we just absolutely see a lot of those connections between what you're doing as a competitor at NHRL and what you might go on to do if you worked at somewhere like NASA.
In general, NHRL is about building bots that are going to destroy each other, which isn't necessarily what we need on Mars, say, but I'm sure there are some really cool innovations in the way that they travel or even the way that they hold their laser arms or whatever. We need these kinds of things if we're going to be traveling around on other worlds. Are there any bots that you've seen that you think would be really cool if we could put them in this non-violent application?
Yes, absolutely. I think we have elements of some of our most innovative bots that already borrow from space technology. There's one robot in particular that is called Dutch Oven. It's one of my favorite robots. And the builder is a guy named Alex Grant. And he just really wanted, flamethrowers have been around for a long time, but flamethrowing robots in our world have never been like the most competitive robots. And he was determined to change that. So he designed this robot, and it's called Dutch Oven because in addition to our community being brilliant engineers, many of them also have the sense of humor of 12-year-old boys. But Dutch Oven, and I think Alex will appreciate me saying that, but he's created this flamethrower that combusts the fuel in a chamber to allow it to exit the robot hotter and larger than in any traditional flamethrower. And that's borrowing directly from rocket technology. And he then, of course, to make Dutch Oven what it is, like in a cartoon where you have a bear trap and it has a claw that comes down, he has basically that kind of a mechanism on the front of the robot. So it's up, and then he pins the robot, his opponent lowers the trap around the robot so it can't move, and then he blasts it with the flame and melts it. And it's just this amazing, hysterical, really entertaining thing to watch. But yeah, I mean, he's literally borrowing from space exploration technology. Again, I think that our sport is greater than the sum of its parts, but in particular, it's like the different components that our builders are working with are things that are so directly oriented and related to the technology that we are using across industries like aerospace and space exploration. And again, it's understanding that we have weight bonuses and all these really strange rules that allow for robots to compete with us and reward them for things like non-traditional motion and understanding mechanisms that are non-wheeled. And so on other terrains where maybe there needs to be other opportunities for how we move something forward or how you self-right or something along those lines, like all of those are elements of what our builders are doing in competitions with us and in their designs. And so they're trying to take all of those considerations into account. And I think that a lot of the way I see robot combat, whether you want to allocate more weight to your weapon or to your armor, whether you want to incorporate non-traditional motion in order to get additional weight, and how you want to use that. There's also just like such an element of strategy to competing in NHRL and problem solving that is really reflective of the NASA work the problem phrase, where like every step of competing at NHRL is working the problem. You have to like look at this really broad picture to understand what kind of robots exist, how they're driven, what works, what doesn't. You have to problem solve within this list of constraints, whether it's the rules or your budget or your capabilities. And then you have to stay calm and focused and dedicated to execute that solution. And you have to stay flexible and amend that plan as needed when reality changes your assumptions. And so you have no idea who your opponent is going to necessarily be. You don't know what configuration that robot is going to use. You don't know what damage you're going to incur. And you have this time constraint to be able to repair your robot and then stick it back in the box against your next opponent. And you have no idea who that next opponent might be after that.
These kinds of skills just cannot be taught in a classroom. There's so much that you can learn out of a textbook, but honestly, it's not until you start fiddling around with something and breaking it repeatedly and working with other people to collaborate that you really learn. And
yeah, there's nothing like putting a robot in a box against another robot and making them completely destroy each other and then having to figure out how to do that and rebuild it. And then to do that and win at one of our competitions, you're doing that somewhere between 5 and 10 times. And so you're really pushing your preparation to the limits, you're pushing your knowledge to the limits and your patience and all sorts of other things.
Are there any partnerships that you have with any educational institutions that allow people to do this kind of crossover where they do these hands-on competitions as a way of learning?
Yeah, I mean, we have so many teams that are high school and college robotics programs and teams that have expanded into robot fighting. A lot of people get involved in programs like FIRST and VEX through their high school or middle school or wherever. And we get a lot of interest in fighting robots from those teams, and educators in particular are taking a lot of interest in what we're doing, which has been exciting to see happen. You know, I think on the surface, robot combat or robot fighting sounds a little intimidating. And there's like a misconception that, you know, it's about one robot dominating over another. And of course, that's true. One robot wins and the robots are fighting each other and destroying each other. But again, it's like when you look at it through the lens of this one being like an absolutely remarkable way to develop and hone your own engineering skills, but also what we've done around like making the community really fun, really like celebratory and exciting, and really kind of eradicating any kind of toxic competitiveness and really more of the collaborative competitiveness. I think it makes it something that has a lot of potential to expand through educational channels. And we work a lot with collegiate robotics programs, and particularly have a lot of teams from Worcester Polytechnic is a prolific team, a really strong team. We have close relationships with Rochester Institute of Technology, University of Cincinnati, Georgia Tech, Cornell, all sorts of schools that come to compete with us. And so being able to build those relationships and support those teams, we've been fortunate enough to be able to give a lot of grants to collegiate robotics programs. We gave $1 million to collegiate robotics programs last year in the form of $110,000 grants. You know, a $10,000 grant doesn't sound like a lot, but we really learned how horrifically underfunded so many of these teams are, and the opportunity that $10,000 was able to afford them, it really paints a picture. So doing more in the education space is huge for us and something that is really strategically important to us for sure.
That's so inspiring to hear, because there's so many people out there that just need their little chance. They need that little bit of grant funding. And we've seen it with our grants. You give away $10,000 to an asteroid hunter, say, and they'll completely change their ability to hunt for these asteroids that could save the world. Just a little bit of the seed money could completely change the arc of someone's life.
Yeah, the financial hurdles are so real. They're not limited to us, but there's an element to like you're coming to a robot fighting tournament and putting your robot in a box and it's going to get destroyed. So you then have to go and pay to repair it and for all of those parts and things like that. So there is like a bit of that turnover that is a bit of the risk and reward that you have to take into account. But knowing that, being able to help to provide any degree of funding that allows somebody who might not have been able to afford to pay to travel to one of our tournaments and to be able to provide those funds. There's so much red tape in all sorts of education systems at all levels, whether it's, public schools in the K through 12 space or collegiate programs that we hear about a lot around the challenges that they have with budget allocations and things just being passed through so many different channels that when it actually finally makes it to them, it seems as if maybe some of it's been siphoned off for football jerseys. But I think that there's definitely an element to which we know that financial hurdle is a huge piece of it. And to be able to do whatever we can in relatively small ways, whether it's we don't charge an entry fee, we charge a refundable deposit to enter. And so to not have a big on the scale of thousands of dollars entry fee throws open the opportunity for educational institutions as well as community centers and organizations. And we do a lot of work with STEM organizations that are also helping to bring in people who may not have access at their own school, in their school district, or because of cost or anything like that. To be able to open those doors is huge for us because it's just part of how we grow the sport and how we get more people into STEM. We've been really lucky to be able to do that.
We'll be right back after this short break.
Greetings, Bill Nye here, CEO of the Planetary Society. When you support the Planetary Society, you support space exploration. That means you are directly involved in making phenomenal moments in space exploration a reality. And that's why I'm seeking your participation in our Beyond the Horizon Every Member campaign. We're in the final phase of our 5-year plan, and we are more than 85% of the way to our goal of raising vital funds that will expand our core mission and strengthen the society. This campaign is critical to our future as the world's leading citizen space advocacy organization, and with your help, we are supporting new science and technology. You will grow the society to make our collective voice on behalf of space advocacy even stronger across the globe. And we are connecting more people of all ages with the passion, beauty, and joy of space exploration. Your gift of any amount today is an investment in the future and will help us usher in the next great era of space exploration. Let's go beyond the horizon. Let's make new discoveries. Let's keep going. Let's change the world.
This is one of those things that really could change the arc of someone's life if they get involved in it. What are some of the most inspiring moments that you've personally seen from the combatants?
I find them all to be just, like I said, I sound so cheesy, but I just find them all to be so brilliant and so inspiring and funny. They come up with these ideas, and I've really enjoyed being able to develop relationships with these builders and get to know them and get to know their designs and get excited and hyped for the things that they're doing. It's to see them all coming together, and I just get really excited. I think it's just so awesome. I love what I do. I love what we do. When people tell me that they find their people here, that's just so deeply meaningful to me. And I've heard that in particular from a couple of moms in our community who have kids who compete with us. And some of those kids are autistic and have a hard time socializing and have had to be pulled out of school and things like that. And as a mom, I can really relate, worrying about the future of your kid and how is your kid going to do, and to hear that from other parents and to see other parents competing with their kids. And I mean, we hear from fans who come to watch the tournaments that this is something that they have struggled, particularly parents of neurodivergent kids have struggled to find a way to connect with them. And there's a dad that I've gotten to know, and he said, my son and I never played catch, but I brought him to NHRL and he was electrified, just lit up from this. And we come to every tournament, and to see that anything that we do just inspires more people to get involved regardless of their background. That's just so inspiring to me, to make it seem like we're doing what we're setting out to do, which is to make a place that people feel like they can come and have an idea and build a robot. And that's just been amazing. And then to see the impact of the philanthropy that we've been able to do has also just been of the highlights of my career, one of absolutely in the upper ranks.
these kinds of collaborations that you're allowing for with these like team building exercises, I've seen what that can do within my field. When I first started out, it was very competitive, people would keep their code to themselves so that other teams wouldn't get it.
Mm-hmm.
But as places online bloomed like GitHub and other repositories for this kind of knowledge, watching people collaborate has really opened up the field. And I'm wondering if there's any new technologies that are coming down the pipeline for robotics that you think might revolutionize not just robot battles, but perhaps the future of space exploration with robots.
Yeah, I mean, I think the world of GitHub is one that, again, not to harp on it, I didn't come from that background. It came from a media world where it was like all about protecting and being a little secretive and all of that stuff, and journalism where it's all about protecting sources and things like that. And coming into this world where let's just make everything open source. I was like, I can't, it took time for me to wrap my head around that concept, but I get it now because I think we see these interactions with members of our builder community who are relative rookies, and they post in Discord and they're like, I keep frying my ESC and I don't know what I'm doing. And then like literally the world champion happens to be in Discord, happens to see that comment in that channel and says, oh, what are you doing? And tell me more about it. And like, here's a picture of the inside of my robot. And like at the next tournament, come up to my table, let me help you. And I'll show you. And to see that kind of collaboration is what we mean when we talk about it being as collaborative as it is competitive, because obviously they're there to win. But in the spirit of engineering, the only way that you know that you're the best is that you're competing against the best. And the way to do that is to be more open about your strategy. And some teams are more secretive than others. And there are some that are quite literally like very secretive about things. To answer the second part of your question, there's a team called Bots FC that competes at NHRL, and they have the reigning 30-pound champion robot. And that robot, for our World Championships event in 2023, it's got a vertical spinning weapon. And the material that they used for that spinning weapon was a top secret DoD material that they had gotten access to through one of them works with in some sort of a defense contractor space. And so they got access to this material and put it into their spinner, and it went up against robots that are constructed out of AR-500, which is, of course, what you use at a gun range to stop bullets. And this weapon sliced through AR-500 like it was a knife in butter. It was just insane to see that. And so to be able to know that in just that tiny little example, an emerging material that is stronger than, but also lighter than really strong steel that is used in so many different applications. Like that's just such a great example of how we can take something that is new and cutting edge and apply it in what we're doing, because we have just focused so much on this like really innovative rule set. And so, yeah, I think that example is indicative of so many other ways that as technology evolves and things become more efficient or more available, that there are more things to experiment with, that all of that with the best builders and the most creative builders who continue to challenge themselves are going to find those things and figure out how to incorporate them.
I'm sure that people who participate in this will learn all kinds of new skills, and who even knows what cool space robots are going to come out of this as a result. For people who are interested in getting involved in this kind of thing, how do they begin getting into the NHRL or other robot battle leagues?
We have open tournaments that are open to everyone. So that's obviously a starting point, is to sign up for a tournament and try to get involved. But beyond that, there are ways that people get started, I guess, a couple of different paths. Of course, we have people who in our community who run small businesses that create robot kits. And so that's often a way that people get involved. As I mentioned earlier, we're launching Havoc Academy, and the first product that we're putting in Havoc Academy is a product called Crash Course, which gives you all of the basic materials and understanding of how all those basic things work. So a battery, a motor, a transmitter, et cetera, and helps you build a little robot that we've designed in-house that is not meant to be competitive at an NHRL event, but it is meant to help you get all of the basics and a curriculum around that. So that's one way that we're trying to encourage people to get involved in the sport and come in with different designs and be inspired to build different things. And then there are people who like just come to the events and come up with this idea while they're watching something and then go home and build it. An example I can think of is there was a robot that competed at our January tournament called Toddler Terror. And it was built by a family of NHRL fans. They're local to our area. They come to tons of events with their toddler. And for Christmas, they built him a robot called Toddler Terror. And it had a flamethrower and it had these little mini bots that had like cotton balls. And the cotton balls lit on fire during the match and we're driving around. And so entertaining and so fun to watch. But like that's an example of just like a slightly wacky approach to coming in. But otherwise, it's like people just, you get an idea. And then, like I said before, join our Discord. There's so many resources there and so many people there who are open and willing to help people get involved. We place a huge emphasis too on safety. Learning the basics of safety is, for us, absolutely one of the most important pieces of what you can do. And we talk a lot about doing dangerous things safely and not being afraid of dangerous technology, but being able to provide an environment for people to learn how to harness it. But the number one thing that you'll hear if you ask a builder is like, how do I do this? Or how do I get involved? Is sign up for an event and build a robot and show up and put it in the box and get beaten and learn from it. And then figure out how you get better every time. And that's the journey that they've all been on.
And it's a journey that we have to go on with every robot we build in aerospace. It's just one of those things that you can't mess up real badly the first time when you're working at NASA. This is one of those things that allows you to really test out your abilities and find those faults in the ways that you're building robots in a safe environment that can then allow for innovation. I can't even imagine what this is going to do for engineers who want to get into either aerospace or any other industry that needs these kinds of robotics. It's really beautiful seeing the way that you're really breaking down these barriers to entry. And I can't even imagine what it's going to do for people in the future. So thanks for doing this.
No, of course. It's an amazing opportunity. And, you know, we hope that more and more people are inspired to get involved and to do this. And it is a place where it's a culture of being unafraid of making mistakes and learning from those mistakes. And at the most elite levels of our competition, the level of strategy that goes into what these builders are doing to prepare is really amazing. They study their past fight footage and their competitors, and really, like it's a football player watching a bunch of tape. It's like they are really excited about what they do, and to see that spectrum of people who are just getting started being side by side and inspired by these people who are just duking it out and coming and putting in the work and putting in all of these reps to be able to do this, is seeing that spectrum just continue to grow and see more and more people across that is just, it's why we do what we do.
Well, thanks so much for joining us, Kelly. And I'll leave all the resources for how you can get involved in this on the website for this episode of Planetary Radio. And thank you so much for helping inspire the next generation of robots.
Thank you so much for having me, Sarah. It was really nice to meet you. And thank you so much for supporting NHRL.
Robot battle leagues are fun, but there are also a lot of other types of robot competitions to get involved in. Many are space-specific, like the European or University Rover Challenges, or NASA's Robotics Mining Competition. Another great one for young people is the First Robotics Competition, or FRC, where high school students from around the world build and program robots to compete in themed challenges. Our next guest is Florence Pouya. Florence is a beacon of inspiration in the world of robotics and a dedicated human rights activist. She played a pivotal role in guiding the Afghan Girls Robotics Team. This extraordinary group, comprised of bright and tenacious young women from Afghanistan, has triumphed over so many formidable obstacles. Their indomitable spirit was evident in 2017 when 6 members of the team journeyed to the United States to participate in the International First Global Robotics Challenge competition. Despite their visas being rejected twice, the team's perseverance and intervention of U.S. officials allowed them to enter the United States and compete. But then, in August 2021, the team's circumstances took a dramatic turn when the Taliban regained control of Afghanistan. Faced with the looming threat of education and freedom restrictions, the team members were compelled to leave their homeland. For many of these women, their passion for robotics and education remained undeterred. Guided by Pouya and the other amazing leaders on the team, these young women's journey is a testament to the transformative power of education and the empowerment in STEM fields, even in the most adverse circumstances. Matt Kaplan, our senior communications advisor and the former host of Planetary Radio, shared this conversation with Florence Pouya at the recent Humans to Mars Summit, hosted by Explore Mars on May 7th and 8th, 2024 in Washington, D.C.
We are very honored now to spend a couple of minutes with a truly honored guest here at Humans to Mars. Florence Pouya is the former captain of the Afghanistan Robotics Team, Youth or Girls Robotics Team, which does have some history with Explore Mars and Humans to Mars, but you are back with us now. Welcome, Florence.
Thank you so much, Matt.
It is really wonderful to have you here and have you participating and to be able to congratulate you on some of the accomplishments, the achievements that you have made here in the United States. You are, I think, a teaching assistant at Iowa State. Tell us what your involvement now is with MIT.
A week before, I just found out that I got admitted to MIT, which is my dream school. I'm so thrilled for that.
Your dream school and the dream of a lot of people interested in aerospace engineering, as you are. Very promising, and congratulations on that. Also named by, is it Forbes 30 Under 30 and Vogue 21 Under 21? That's a lot of accomplishment for someone as young as you.
That's true. Being named in Forbes 2021 was a great accomplishment for me and my teammates, and it was mainly because of building a ventilator during the COVID-19, and also another machines for helping patients and doctors during that time.
That's great. When I look at what you are achieving and the future that I certainly expect you have ahead of you, I cannot help but think of some of your teammates and the other young women who are still in Afghanistan and the potential that may be lost there for them to contribute as it looks like you're already contributing.
I'm trying my best to be a voice of thousands and millions of girls in Afghanistan who have not the right to go to school or university, which is very normal for any other girls in any country to do that. Being in a conferences like this, it's a great honor for me, and it's a great opportunity to show the talents and the power of Afghan women. I believe if they be given the opportunity, they can be even perform better than me, or they can even be better scientists, engineers, and people who can be involved in the development of their countries.
Well, you're setting a pretty high bar for them to meet if they have that potential, but perhaps. Do you see any hope for the young women in Afghanistan who would like to follow in your footsteps? And are you in touch with any of your old teammates?
At this one, I'm really hopeful for a better future for all the girls in my country, Afghanistan. And I'm trying my best to be a good example for them. My long-term dream is to be the first female astronaut in Afghanistan, because I know there are many girls in Afghanistan who have the same dream, but because there was no girls before them to do that, they kind of see it as an impossible thing. So I want to be kind of a role model for them and kind of show them if they want to, and if they really try, they will accomplish that, or they can reach their goals. I am in touch and in contact with some of my friends back in Afghanistan, and talking to them sometimes make me really sad because they were my classmates in high school or in some other courses, but now they stopped their educational journey and they are just in their house and they cannot do anything. They are just hopeful that one day the school and university be open again for them, and they can go to university and pursue their dreams.
Are you familiar with the Latin phrase ad astra per aspera?
Not really, to be honest.
It means, and there are different variations on the translation, but to the stars through struggle or through hard work. And so the struggle that your old colleagues at Afghanistan and the challenges that you are facing are an inspiration, I think, to all of us. And I wish you and them the greatest of success.
Thank you so much. And I really hope that all the world leaders and people who really can do something, they do not forget girls in Afghanistan, try to provide them with opportunities, some scholarship, and do not leave them alone. Thank you so much.
Thank you for that as well. And I'm glad that you will be joining us for what has become the traditional close for the Humans to Mars Summit, that big inspirational panel that we will have standing on the stage. Thank you again, Florence.
Thank you so much, and looking forward for that.
Next, let's check in with our chief scientist, Dr. Bruce Betts, for What's Up. Hey, Bruce.
Hey, Sarah, I hear it's robot fighting time.
Robot fighting time. No, really, though? How much fun would it be to go to one of these robot battles?
Very fun. I've looked into it before, but never made it there. My sons and I used to watch all sorts of these things all the time, but maybe we can in between playing video games and role-playing games.
Your life is so busy, Bruce. But now we all have an infinite invitation to go check out that Robot League. I feel like a Planetary Society field trip to go watch some robots throw down would be super fun. I've always wanted to get into robotics, but as a kid, the closest I could get was watching battle bots and these shows on TV. I didn't have the tools as a kid to actually build these things. So it's really cool seeing that now there are entire leagues that are teaching whole new generations, both younger people and adults, how to do this. How else are you supposed to get into building rovers on Mars if you don't have any experience in building these? And then, we'll have rovers on Mars with giant blade saws someday.
Nice.
Something that Kelly and I spoke about, which didn't manage to make it into the episode, was actually about how the robot battles have changed since the introduction of AI and large language models into the kind of common ethos. People are using these tools for all kinds of cool stuff, everything from avoiding writing their own essays to creating their own music, but they're using them to try to create these autonomous reactions for these robots, which is something that's very useful in space exploration. Just because of that communication distance, I can't even imagine what it would be like to try to land on Mars without these autonomous navigation systems.
Well, you couldn't.
Right?
Our distance to Mars, we're talking, depending on where it is, many minutes, and the whole descent is 7 or 8 minutes from the space to the surface. And so it's all autonomous. So NASA's been doing autonomous and others have been doing autonomous for quite a while. And the rovers are built with more and more intelligence, so to speak, and capability to act on their own. And then it's always a trade-off of how much do humans get involved, because there's this time delay signals going out, coming back, getting interpreted. And so they set them free to go a little ways on their own. And I'm sure it would just be a hop, skip, and a jump to adding autonomous buzzsaws. I mean, technically they have things, they have lasers that make holes in rocks. They have the rat from the previous thing, which had a cool acronym and would grind rocks. They have drills. So, I mean, they're pretty much halfway there. You could take 2 of these and have the slowest, most scientifically understood battle between 2 multi-billion-dollar rovers. It would be awesome. Actually, it would be really boring.
If you could take every rover on Mars, past and present, and put them into one giant robot battle with each other, which rover do you think would win?
Well, it's a tie between Perseverance and Curiosity, but yeah, I'd go Perseverance. You got a deeper drill so you can really penetrate into the other robot and help destroy it. So I'm going to bet on Perseverance. SmackDown, one night only. Perseverance versus Curiosity. Be there.
I would pay to see that. All right. What is our random space fact this week?
Random space fact. An amazing amount of uncertainty about the rotation period, the length of a day on Eris, that relatively big, almost Pluto-sized trans-Neptunian object out there. So there have been publications since the discovery of Eris in 2005 that have thought there were rotation periods of anywhere from 3.5 hours to 16 days. The last kind of number people floated, you can still find on NASA sites on the internet, is around 26 hours. But there have been 2 studies recently from Bernstein et al. And Zakats et al. That did a bunch of different techniques to measure the rotation period. And it turns out to be this 15.8 days, and it is synchronous locked rotation with its moon, Dysnomia. and that surprised some people, but it's interesting. And they also derive from that, like the evolution of the system. It's probably an impact generated moon. So it's just amazing to me. But it turns out we often do the rotation periods using light curves. And so it's done with asteroids, for example, and the asymmetry in the reflection causes you to see repeat patterns. You come up with how long it takes to rotate. Well, it turns out not only is Eris a gazillion billion miles away, that's not a technical term, but it also has like 3% variation in brightness. And so you have to have long-term views of this very slow-moving object, slow rotator, slow revolution, and you have to have good photometry, good calibration, so that when you compare things from now with something from 6 months now. Anyway, they've done it, and there you go. So that's what I found when I'm like, hey, what's the rotation period of Eris? Oh, turns out a bunch of different numbers on the web, but I would go with those because two groups, each with multiple independent sources, have come up with this synchronous locked rotation with dysnomia. Congratulations, Eris and dysnomia. You're looking at each other, unless you're on the opposite side of them, in which case you never see that the other one exists. Okay, there we go. Long, but I thought it was sort of interesting.
It's really cute, actually. I've always felt like Pluto and Charon as a pair, tidally locked to each other, just kind of dancing in space, was really cute. But now I know that Eros and dysnomia do it too.
There are others of the trans-Neptunian objects. That there's at least a handful of others that seem to be as well. And so obviously when you have big size differences, you end up with an Earth-Moon situation where the little one, so to speak, ends up locked. All the Jupiters, all of its inner moons, Saturn, they're all locked towards the planet, but the planet doesn't really give a darn about what they're doing gravitationally. So that there is an effect, but it's tiny.
That was actually a homework problem I remember once doing. Like, how long will it take the moon and the Earth to be fully tidally locked to each other? And it was honestly longer than the lifetime of the sun, something like that. So not something we have to super worry about.
Measured in many billions of years, as I recall.
Yeah.
But yeah. Anyway, there you go. All right, everybody, go out there and look up in the night sky and think about if your car was automated and you had a giant demolition derby. Would your car be able to win in an automated giant demolition derby? And what weapons would you put on it? Oh, this is so exciting. Thank you and good night.
We've reached the end of this week's episode of Planetary Radio, but we'll be back next week with a discussion on international collaboration in space with representatives of the US, Europe, Japan, and the United Arab Emirates. Love the show? You can get Planetary Radio t-shirts at planetary.org/shop, along with lots of other cool spacey merchandise. Help others discover the passion, beauty, and joy of space science and exploration by leaving a review or a rating on platforms like Apple Podcasts and Spotify. Your feedback not only brightens our day, but helps other curious minds find their place in space through Planetary Radio. You can also send us your space thoughts, questions, and poetry at our email at planetaryradio@planetary.org. Or if you're a Planetary Society member, leave a comment in the Planetary Radio space in our member community app. Planetary Radio is produced by the Planetary Society in Pasadena, California, and is made possible by our dedicated members, who I'm sure would be an absolute blast to hang out with at a robot battle. You can join us and help empower everyone to reach for the stars at planetary.org/join. Mark Hilverda and Ray Paletta are our associate producers. Andrew Lucas is our audio editor. Josh Doyle composed our theme, which is arranged and performed by Peter Schlosser. And until next week, Ad Astra.